everybody, this is Miss Abney. I'm here for topic 1, lesson 2, example 1. We're going to take that vertex form that we were working with in lesson 1, and we're going to move it into this lesson 2, and we're going to figure out how to find bits and pieces of our standard equation so that we could go from our standard equation into vertex form and vertex form into standard equation, and that we can actually find that vertex. So just really fast, a reminder of what the vertex is. So if I have a quadratic formula, it doesn't matter if it's a vertex form or if it is standard form, it will have this standard parabola shape. And at the very bottom of this parabola, again, is your vertex. And that vertex, around that vertex, we have what's also called the axis of symmetry, which basically means that if I had a line going through this vertex vertically, the left side will look exactly like the right side. So this is our axis of symmetry. And so that vertex is an actual very important point. Again, it either tells us the minimum or maximum of our parabola, it tells us where the axis of symmetry is, it actually can tell us how this parabola has been transformed, going left or right, up or down. So there's a lot for our vertex. So let's start this one. So how can you find the vertex of the quadratic function written in standard form? And what is the x-coordinates of the vertex of f of x, ax squared plus bx plus c? So we're looking for just the x-coordinate of the vertex. So I'm going to write this in vertex form. F of x equals, or I'm going to write out vertex form, not this guy yet. X minus h squared plus k. Just to remind you what vertex form really looks like. Now what I'm going to do is I am going to expand my vertex form. And remember that this right here gets expanded into two different expressions. So then we do f of x, and I'm going to use FOIL, x squared minus 2hx plus h squared plus k. All right, next I'm going to factor in that a. So I have ax squared minus 2ahx plus ah squared plus k. All right, so we know that these two are constants. Because h in this is a constant, a is a constant, and k is a constant. So this actually, if I'm looking at my original, let me get this in black here. I'm going to look for each piece. It's like a puzzle. I'm looking for the piece. Looking at this is going to be my constant. So c is going to be equal to ah squared plus k. Right here we have this x and we have this x variable there, a single x variable on both of these. We've already eliminated this as being c, so these are the only two terms we are working with. And these are the two terms that both have just a single x. So now I can say that b is equal to negative 2ah. Eliminates that term. Again, we're just seeing which terms relate in both equations. The last one is ax squared equals ax squared. So a in this case is equal to a. There's nothing spectacular about that. We don't have to worry about this one. And there are no h and k's in this last one, so I'm just going to erase it. All right, so we need to find our h because they want us to find our x coordinate. And our x coordinate for the vertex is h. Remember, this is h comma k. Our x coordinate is the h. I'm looking at my two equations here. This one involves k. That's kind of extensive. We would have to find a value for k in this one. Well, the b equation only has a, b, and h. So what I'm going to do is I'm going to use this one to solve this. This is purple. So I have b equals negative 2ah. And again, do you have to go through this whole process to find this? No. What this example is doing is producing a formula for you to use every time so that you can find h just easily. So whatever the end product of this is, that is the formula that you really want to box and star, because that is the formula that you are going to use to find h. All right, so I need to get h by itself, so I'm going to divide by negative 2a. And what I get is h is equal to negative b over 2a. So this is what you need to box. This is what you need to star. You know, I think I have creative pen. I think I have stars, so I'm going to box this in stars. Bam, because that's important. So if this takes any formula that you have and find your horizontal translation. So in this case, if I have this standard form, I could find h extremely easily as long as I know that this is a, this is b, and this is c. So this is negative 3 over 2 times 2. And the negative is in the formula, so make sure that follows through. So this is negative 3/4. This would be my h. This would be my horizontal translation. So again, going back to the book, we have the standard equation as ax squared plus bx plus c. We're going to write out the vertex form, basically find h using this idea of ax squared plus bx plus c. And then we will be able to find the h coordinate or the x coordinate for my vertex. So guys, I hope you find this video at least a little bit helpful, and I will see you in the next video.